Hello, welcome back to Byte Forever. Today's episode, if you'd call it that, we're going to just look at a little bit of ZX81 assembler code. We're going to assemble it using the tasm assembler, and then we're going to run it in an emulator first, and then we're going to convert that program file, the .p file, into audio file, and we're going to then run it on the real ZX81. So I'll put links to this to GitHub in the comments, sorry, in the description. There's credit to a few things we've got as comments. Essentially what this program does is to use sort of arbitrary, almost arbitrary precision arithmetic. So I've got some routines here which can handle 32-byte numbers. So they're all called things like hprint 256 and sum 256. And the interesting thing is that you could extend this effectively to use the full amount of spare memory on the computer, on the ZX81, which admittedly is only 16 kilobytes, but you could do that because it's just an iteration of this process of doing an add and then an add with a carry repeatedly. So the add with carry, for those of you who don't know, will add and then set a carry flag if the number that you've just resulted in overflows the 8 bits, because it's an 8-bit CPU. And yeah, so this is there's not much code here actually in the end. There's a few things I call CLS at the end of each screen full, just to clear screen, because if you were to scroll this using there's a command, there's a run routine to scroll screen, but it's too slow if you do that. And effectively what I'm doing is just 36 screenfuls, and then it stops because I've tuned this to, that's when effectively run out of the number of bits it overflows after that. Okay, so what I'll do is just run this in an emulator. I'll bring the file up, so that's not the right one, that's the ZX to WAV utility, which I used actually to create an audio file that I can load into the real ZX81. So running in an emulator, we're running this EightyOne, which is a really cool ZX81 emulator. I'll try and put a link to that in the description, but you can find that pretty much anywhere on the Google search. So here it goes. So you can see each set of 2 lines is one of the numbers, and it's printing the least significant bit in hex. This is all hexadecimal print at the right hand side there. So there you go. So it's run through the whole thing, 36 screenfuls, and these last 2 lines are the final number in the sequence, Fibonacci sequence, that I've been able to calculate. Obviously it's not the final number, it goes on infinitely, I guess. Probably some mathematicians will be able to elaborate on that in the comments if you like. But yeah, I've got 256-bit number in Fibonacci sequence. It's probably quite easy to extend this to 512 bits. Obviously these numbers are growing very quickly, so it would obviously take a lot longer to run this as well, the more bits. And I think practically speaking you'd only want to do sort of one if one digit was a full screen. So that's, I suppose you could do, what is it, it's 32 characters by 24 characters, although for some reason you can't quite do the full 24 characters because it exits with a 5/10, which is that it's run out of screen, which is a bit of a shame. Anyway, so that's it running on an emulator. What I thought it'd be fun to do is run it on the real ZX81. So what I'm going to do, I've primed this up now. I've got the WAV file, which is again a conversion from this program file into an audio file. Play it with Windows Media Player, down the headphone output into the ZX81, which I'll actually show running. Okay, so the audio file's playing, it's about 37 seconds. I'll just show you the setup of the ZX81 again. It's got the RAM pack on. Yeah, so it's loading so the screen's blank. Get no signal on there. And here we go. So with the contrast it is a little bit difficult to see. I need to get basically a composite video screen grabber that I can go directly to the PC and put this in. It'll be a lot clearer then. But yeah, there it goes. The bottom number's counting down to 0. When that gets to 0, it'll stop. And the results, in theory, should be the same as on the emulator, and it is. There you go. So this number 01D all the way across, ending in AC11. That's the final number in the sequence that I managed to calculate. What I'd like to do is probably see how far I can take this extending it to use pretty much the whole of the memory on the ZX81. I don't really have an estimate of how long that'll take to fill to get a number that is that big, but I think that would be an interesting thing to do. And anyone checking the links in the description, feel free to go to GitHub, and if you like, you could try extending this program. Obviously I'll try and review it at some point if you've got any changes, or you can just do a video response. Would be quite cool, just to see how far you can take this. I mean, I'm interested in these number sequences, and also you've probably seen one of my earlier videos, which is the calculation of the constant E based on actual logarithms. Also, this isn't floating point, obviously, this is just integer, but it'd be pretty cool to try and extend this bit of code. Now I've got this in integer, maybe add a floating point, arbitrary precision arithmetic. That would be quite cool to do. Okay, as always, thanks for watching. If you like the video, press the like button, and if you like the content on the channel, please subscribe. Okay, bye for now.